Mean and variance of Poisson distribution. First, we derive both by direct method, and at the end of the video, we derive the values uh, from binomial distribution entities without any lengthy derivation part. Suppose the question is given as a part B question, the 8 marks like we use direct procedure, and if it is given in 2 mark case or the question may contain or insisted that entries of mean and variance should be derived from binomial, then we use the alternate procedure. First we uh, go through the direct derivation part. Mean E of x, expected value of x is sigma over I, over r x r p r. The index is here wrongly entered as I. It is simply r, small r. It means sigma varying from r is 0 to infinity. The random variable values is here r, and the respective probability value is p of x equal to r. And if we write the probability mass function equivalent p of x equal to r, it is e power minus lambda, lambda power r by r factorial. Then the next step we are taking lambda and e power minus lambda out, because one lambda is taken because we are going to cancel that r and r factorial r, and the balance is r minus 1 factorial in the denominator. So for uniformity, lambda power r is splitted as lambda power r minus 1 into lambda, and that one lambda is taken out. Now this is in the format which is equivalent to e power lambda. So finally we get lambda e power minus lambda into e power lambda. E power minus lambda and e power lambda becomes 1. So the answer for this mean derivation is lambda. So e of x is lambda, which is mean. And both the expansions and simplification steps are given in the end of the slide. They are highlighted by this encircled area. Now variance is going to be obtained in the next part. Variance of x is e of x square minus e of x the whole square. E of x just now we obtained, so we want now e of x square. E of x square is same procedure, sigma x x r square p of x equal to r, varying from 0 to infinity. Random variable value is r, so r square e power minus lambda, lambda power r by r factorial. See, we cannot proceed with this r square, so one r is add and subtracted from this r square term, so that we can split the whole summation as two summations. One is with r term and another one is with r square minus r, which is factorized as r into r minus 1. So e power minus lambda, lambda power r by r factorial is taking as a common entry, and this r square minus r plus r is splitted as two entries. With first summation we are going to derive, and the second summation part is simply e of x. Just now we obtain the value as lambda, so directly we can write it as lambda, and the first sigma come to this r and r minus 1 in the numerator, and this r factorial contains r and r minus 1. Cancel both of them. While cancelling, 0 to infinity becomes automatically 2 to infinity. Now after cancellation we get e power minus lambda, lambda power r by r minus 2 factorial. Sigma is varying from 2 to infinity plus lambda. This r minus 2 factorial is in the denominator and lambda power r is in the numerator. Uh, Whenever we have r minus 2 in all the places, we can compare with the e power term. So lambda square, lambda power r is splitted as lambda square into lambda power r minus 2, and lambda square is taken out. So the next step, final step of this slide is contain lambda square e power minus lambda, both the terms are taken out. Balance sigma is 2 to infinity lambda power r minus 2 by r minus 2 factorial plus lambda. This is e power lambda. Total sigma term is e power lambda, already outside lambda square and e power minus lambda. So cancelling this e power minus lambda and e power lambda, we get 1. So lambda square plus lambda is the value of e of x square. Variance calculation, we use this term and already e of x the whole square term. So lambda e of x square minus e of x the whole square, which is lambda square plus lambda minus lambda the whole square. So cancelling this lambda squares, we get lambda for variance. So mean as well as variance both are lambda for Poisson distribution. Both are completed by direct derivation. Now come to this binomial derivation. Mean and variance both are obtained using binomial distributions, mean and variance, that is the entities from binomial random variable. E of x is NP for, that is mean is NP for binomial distribution and variance is NPQ. Come to this mean of Poisson distribution. So the respective limiting conditions we apply here, n tends to infinity, automatically NP becomes lambda. Directly we can write the mean, that is E of x is lambda. When variance is taken, limit p tends to 0 is applied because we have one more term q here. So it is better to use p tends to 0 because np is already taken as lambda under these conditions, and q is written as 1 minus p, and p tends to 0 implies 1 minus p becomes 1. So this is also gives lambda for variance case. Hence E of x is lambda and variance of x is also lambda for Poisson distribution using binomial distribution.